Hey guys, what's up? It's Eric with Advanced Level Automotive. Welcome back to the channel. Welcome back to another video. Today, we're taking a look at this 2011 Dodge Ram 5500 pickup truck. This thing's got the 6.7 liter diesel engine. The customer complaint is that this vehicle is overheating. What he's telling me is that it's already been to 2 different shops, and I've actually got some invoices here showing that they replaced the oil pressure switch, they replaced the coolant temp sensor, and they replaced the fan clutch. And so after doing all of that, the vehicle is still overheating. Now, what he's telling me is that it mostly overheats when he's pulling a load. And so if he's got something loaded down, because this is a flatbed truck, and so if he's got the flatbed full of material or whatnot, then the vehicle does tend to overheat. And so initially this was the message that got him to realize that his engine was overheating. And so like I said, after that, he took it into a shop. Now at the first shop that he took it to, that's where they replaced the oil pressure switch and also the coolant temp sensor. And from the first shop, it went over to the next shop where they replaced the fan clutch. Now the second mechanic did tell the customer that he thinks the truck needs a PCM. So at that point, the owner decided to bring me the truck so I could double check it. Now I know a lot of you guys have been asking me, why don't any of my videos have any diesels in them? So I figured this was a perfect opportunity for me to put a diesel in one of my videos. I've actually done a lot of diesel work in the past, back when I used to have my shop. Anyway, I hope you guys stick around for this diagnostic. Let's go ahead and move inside the truck, hook up the scan tool, and I'll show you what we got. All right, guys, so inside the vehicle, I've got the key right here. I'm gonna stick it into the ignition, turn the ignition on, and what I have here is our scan tool that we're using today, the THINKTOOL Pro. And so I'm gonna go ahead and click on diagnosis, and we are going to run a quick code scan. Let's go into American. We'll go into Dodge, hit OK. We'll do an automatic search for the VIN number here. Tells us this is a 2011 Dodge Ram. Again, it's a 5500 with a 6.7 liter diesel engine. We'll hit OK. Now we're gonna go into our system selection, and I'm going to select the PCM. Then we're gonna start by reading fault codes. So we're gonna click on that, DTC information. And here we have our 2 fault codes. Now taking a look at these 2 codes, you can easily guess which one we're going to be focusing on. Again, we have an overheating condition, so this cooling fan code is the one we're going to be focusing on. And so P0692, again, our description here is cooling fan 1, control circuit high. Again, if you guys recall, I mentioned that the second mechanic actually replaced the fan clutch. We can easily assume that this code more than likely was set by the last mechanic who replaced the fan clutch. And so the first thing I'd like to do before I get ahead of myself is actually back out of this menu. And what I want to do is I want to try to clear the fault codes, and I want to see if they come back. So it's asking me here, are you sure if you want to clear the fault codes? We're going to hit yes. And you can see the message it's giving us here. Clear fault code succeeded, but the DTC is still present. Please check. And so let's go back into this menu here. Read fault code, DTC information, and let's see what fault code came back. Bam, check that out, guys. Immediately, both of these fault codes came back. And so what does that tell us? That tells us that these 2 fault codes are hard fault codes, meaning they're happening right now. Again, I'm not worried about this P203F. This is just letting us know that our DEF fluid is low. We'll double check the bottle, and we'll be sure to recommend the customer to refill the DEF fluid. Our main concern here is with the overheating, and so we're going to be focusing on this P0692. So now that we know what code we're dealing with, let's go ahead and move over to the computer, see if we can pull up a code description so that we can get a better understanding of how this code gets set. All right, guys, so over here at the computer, I've got all data pulled up. And what we're looking at is our code description for our P0692 cooling fan 1 control circuit high. So if we scroll down, you can see that they do give us a brief wiring diagram. However, I do want to scroll down to the code description. Here we have the theory of operation. So if we read this, you can see that it tells us the cooling fan is a hydroelectric controlled device that is engine mounted. The PCM, or powertrain control module, monitors various sensors to control fan speed. The cooling fan provides temperature control for engine coolant, engine charged air, AC freon, and automatic transmission fluid. Fan speed increases as cooling requirements increase. Since the fan is mounted to the engine, fan speed is related to engine speed, also known as RPM. The PCM uses a pulse width modulated, or PWM, driver to control the amount of fluid to the clutch fan. When the fan is fully engaged, it is capable of speeds about 10% greater than engine speed. The fan will rotate anytime the engine is running, even when the PCM is not sending a pulse width modulated signal. So there's our brief description of how the system works. Now, if we scroll down here, you can see that it gives us a set condition. It tells us the smart power relay is commanded on by the PCM and feedback voltage is reading high. Okay, so that's pretty straightforward. So if you look down here, they give us a list of possible causes. First of all, we could have our fan clutch supply circuit shorted to voltage. We could also have our fan clutch supply circuit open or have high resistance. or we could have actuator ground circuit open or high resistance. And then we could also have a problem with the radiator fan itself, or we could even have a problem with the PCM. So if we scroll down, you can see they give us basically a manufacturer flow chart. And so over here it tells us if we have the active DTC, turn the ignition on, use the scan tool to record all freeze frame data. Also it says using the scan tool, erase the DTCs, which is something we already did. Turn the ignition off for 75 seconds, then turn the ignition back on. Using the scan tool, read the DTCs. So it's asking us here whether or not the DTC reset. If yes, go to 2. If no, continue on. However, ours did reset, so if we scroll over down to 2, it tells us to check the clutch fan supply circuit for a short to voltage. Also to check the connectors, clean repair is necessary. It's asking us if the voltage is reading near battery voltage. If yes, then repair the clutch fan supply circuit short to voltage. Very basic information. I mean, they're not really giving us any detailed procedures for actually finding our short to voltage. They're just saying that, hey, if you got a short to voltage, you need to find it and repair it. So, I mean, a lot of times these manufacturer flowcharts don't give you a whole lot of information. I honestly rarely even look at them. I just kind of want to give you guys a brief overview of what they're giving us here. And so it says that we should also check the clutch fan supply circuit for an open or high resistance. Basically, if we have high resistance in the circuit, then they want us to disconnect the PCM, then also disconnect the fan clutch, and they want us to do resistance measurement between the connector at the PCM and the connector at the fan clutch. Very general information here. Nothing is really specific. Again, if we continue to scroll down, it wants us to check the ground circuit also for an open or high resistance, pretty much in the same way that we did to check for the power circuit. If we continue to scroll down here, they tell us to check the radiator fan clutch by essentially doing a resistance measurement across the fan clutch. So yeah, I mean, this is useful, helpful information. They do give us a resistance measurement here for the fan clutch. However, you know, our fan clutch is brand new, and so I find it highly unlikely that we're going to have an issue with the fan clutch itself. So let's scroll back up and take a look at our wiring diagram. All right, guys, so here we have the wiring diagram for our cooling fan clutch. And so starting here in the center, you can see that this is our powertrain control module, also known as a PCM. And then down here we have our drive fan radiator, which is our fan clutch. And then over here we have the engine coolant temperature sensor. And then up here at the top we have our TIPM module, or our totally integrated powertrain control module, also known as the fuse box. And so if you look down here at the fan clutch, you can see that we do have a description for each of the wires that goes to the fan clutch. So if you look over here, you can see the description says clutch fan 12 volt supply. And so this is going to be our 12 volt supply voltage that comes from the PCM. And you can see it comes in on this brown and light blue wire. And then if you look over here, you can see this is our high side return, this brown and pink wire. So this is going to be the ground returning back to the PCM for our fan clutch. Now these other 3 wires over here are going to be for the fan speed sensor. And so this is a 3-wire speed sensor. And so if you look over here, we have our 5 volt supply. Over here we have the sensor ground, and over here we have the sensor signal. Now our code description is pretty specific. It pretty much tells us that we're having an issue here on the fan clutch control 12 volt supply circuit. And so this is where we're going to go directly to when we do our checks. And then we're also going to be checking our ground connection going back to the computer. Now what's really interesting is that if you look up here, you can see that we have this power feed. It says ignition run start control output. And so this is a power feed that comes in on this pink and gray wire that actually comes from our TIPM module or our fuse box. And so when we look at the way this diagram is laid out, there's a reason why the manufacturer put this power feed input on this wiring diagram, and that's because it has something to do with our cooling fan control system. And so the power supply that comes in on this brown and light blue wire for the clutch fan control has to come from somewhere. And so if you look at the way they drew up this wiring diagram, more than likely that power is coming from our TIPM module on this pink and gray wire. So as a quick overview, once again, our power comes in from this TIPM module through this pink and gray wire. It goes into the PCM, and from there the PCM uses that power supply voltage to feed the control circuit on our clutch fan. It comes out through this brown and light blue wire, which reaches our clutch fan. And then we have the ground side over here on this brown and pink wire coming back to the PCM. Now, again, this is a pulse width modulated duty cycle control. And so depending on what type of design the engineers put, we could either have a pulsed ground over here on the ground side, which means that our 12 volt supply is a 12 volt supply at all times. And then when it comes back to the computer on this ground, the computer is going to pulse the ground to create our duty cycle. Or it could work the other way around, in which our voltage is pulsed on and off from the powertrain control module. It goes through the fan clutch, comes out on the ground side through this brown and pink wire, and this ground at the PCM is a ground at all times. And so I'm not exactly sure what type of duty cycle control we have here, whether it's a pulsed ground or a pulsed power feed. The manufacturer doesn't give us any of that information here. That's something we're just gonna have to figure out when we get to the vehicle. However, I will say that it's more common to see a pulsed ground, pulse width modulated control system. They seem to be the more common ones amongst a lot of the vehicles that I've run across. But like I said, we'll find out once we start poking around. And so the next thing we want to do is go back over to the vehicle, start by back probing our fan clutch here at pin number 6 on this brown and light blue wire, which is our power feed for our control circuit. And we want to make sure that our battery voltage is actually reaching the fan clutch. And if it is, then we're going to go ahead and check our ground, make sure that we have good continuity to ground back to the PCM. So now that we understand how the system works, let's move back to the vehicle and do our checks. All right, guys, so moving under the hood of the truck, let me show you where the fan clutch is located. Right over here, you can see this big yellow fan. And if you take a look right there in the center, you can actually see that this fan clutch nut in the center is nice and shiny, indicating that they did in fact replace the fan clutch. Now, if you take a look right here, this is our actual connector for the fan clutch. And so you can see this part of the connector is part of the wiring that actually extends from the fan clutch. And so if I move this shroud over a little bit, we might be able to get a good visual of it. I'm not sure how well that's going to show up on the camera, but I'm trying to get you guys a good view of the front of the fan clutch. So if you take a look right there in the center, the nice shiny silver thing, that is our fan clutch. And the piece on the front of it is the electronic part of the fan clutch. And so you can see how the harness extends up toward here. And eventually they make their way out through this side here and come out to the connector. Now over on this side, this is the harness that comes from the vehicle's computer. And so first of all, you guys can see that it is plugged in. We can actually do a little tug it test where I'm going to try to pull it. And it's not coming out. Let me try pushing it in a little bit further. And it seems to me like this thing is connected all the way. Now doing a quick preliminary visual inspection, I don't see any kinks in the wiring here. Taking a look at where this wiring comes from behind the fan shroud over to the connector right here, all of that seems to be in good shape. Then looking at the harness side here and following it up, you can actually see that, well, actually this piece right here looks like it came off of this plastic clip here. And so this looks like this is where the harness is supposed to be mounted. That does kind of concern me because this harness could have been rubbing up against that fan. Let's take a quick look at it. Okay, so looking at the harness, I don't see anywhere where there's any damage. And so visually, this still looks good to me. Let's follow that wiring harness up through here. And at that point, you can see that it joins the rest of the harness here. Then there are several other connectors that branch off from this harness. However, our fan clutch is directly connected to the PCM, and our PCM is located down there, bolted up to the side of the engine. I don't know if I'm gonna be able to show you guys this on the camera. However, way down there is our PCM, and I can tell you right now, I don't see any obvious signs of wiring damage. And so our visual inspection so far looks pretty good. Now, I do wanna concentrate a little bit more on this connector here. So what I wanna do is I wanna actually disconnect it, and I want to make sure to see if any of the pins are bent or damaged in any way. So let me disconnect this. I'm just going to squeeze on this clip and pull on this, and there we have it. Now let's take a look at these pins coming out of the connector here. You can see that we have 5 of them, and they all look to be in pretty good shape. Okay, let's take a look at the connector over here. Okay, so looking at it from this side, you can see our female terminals. They look to be in pretty good shape. I don't see any corrosion or any obvious signs of damage. I mean, we could try to do a pin fitment check, even though this is a brand new connector, because it is part of the fan clutch. All right, guys, so before I go off checking pin fitment on the other connector here, I kind of want to take a look at this harness where they put this tie strap here, because I'm wondering if something happened that caused them to have to do this. And so I'm just going to take a pair of scissors and I'm going to cut off that little tie strap. And then we're going to take a look inside. Open this up. Now here we have our exposed wiring harness. However, I don't see any damage here. All right, guys, so moving on to the next step. I've got my lab scope up here on top of the truck. And here we have the connector for our fan clutch. Now we're going to start by checking these 2 wires here. We have the brown and pink and the brown and light blue. The brown and light blue is our power source coming from the PCM, and the brown and pink is our ground. So I'm gonna go ahead and start with our brown and light blue wire, which is our main power feed. And so I'm gonna be using this little piercing tool. You guys have seen me use it before. I really like this because it has those little fine spikes right here, little bed of spikes that are really good for piercing the wire. Now, I did try to slide a back probe into the back of this connector. However, this weather stripping is pretty dry rotted, so it's hard to get through it. And I wanna be sure that I have a good connection. So I've decided to go the route of using this piercing tool. So I'm just gonna go ahead and clamp it on. Then we'll plug in our connector. Now let's go ahead and start this truck up. All right guys, so taking a look at the lab scope here, you can see on our graph, we're showing a flat line and we are at 3.91 volts. Again, if you guys remember, we're on the brown and light blue wire, which should be a 12 volt power source coming from our engine computer. We're only showing 3.91 volts. So already there's definitely a problem here. So I'm gonna carefully unclip this. Let's pay attention to the meter here. Okay, so our connector is disconnected. Take a look down here and we're still at 4 volts. All right guys, so a little tidbit I wanted to add really quick to explain to you guys my thought process at the time, because I am recording this after the fact, so I already know what's wrong with the truck. However, I wanted to explain to you why I got a little bit sidetracked here. And so, of course, when we went to the fan clutch and we checked for power at pin number 6, which is our brown and light blue wire, we found that we didn't have our 12 volts here. We only had 3.9 volts. And so immediately I started to think that we had high resistance somewhere in the circuit, some type of voltage drop. My mind was focused on finding maybe some damage in this wiring leading back to the computer, trying to find where our voltage drop is located. Maybe it's possible that our voltage drop is happening inside of the engine computer. Maybe we could have high resistance in the circuit coming from the TIPM module on this pink and gray wire. Those are the things that were going through my mind at the time. And so the next few tests that you're going to see in this video is basically me looking for some type of voltage drop, even though, as you'll soon find out watching the video, I was totally misled by this 3.9 volts. You'll see why if you just continue watching. But anyway, I just didn't want to erase any of these scenes because these tests are still valid if you're dealing with a circuit that has high resistance somewhere. Also, I don't want to erase these scenes because this shows what happens in real life. Sometimes we run across a system that we're not familiar with, and in this case, this led me down a little bit of a rabbit hole, and I almost came to the conclusion that we had a bad engine computer. Luckily, I was able to figure it out before I did something stupid. So anyway, I just wanted to add this little explanation. Let's continue on with the video. And so the first thing I want to do is something that I like to call a wiggle it test. And this is a pretty simple, straightforward test. We're connected here onto this wire. And what I'm going to do is I'm basically going to play with the wiring harness. I'm going to move it around and we're going to watch the meter here and we're going to see if our voltage comes back. I'm going to stick my arm way down in here so I can reach the PCM. Yeah, that's the PCM right there, bolted up to the side of the engine. And so I'm going to wiggle the harness and we're just going to watch the meter, and I don't see any change. All right, guys, so I went ahead and I removed the TIPM module, also known as the fuse box, or the fuse box, also known as the TIPM module, however you want to say it. Either way, you guys can see that I went ahead and I unclipped it all the way around and I pulled it up out of the case here. And I used the bungee cord just to hold it up. And I was able to locate our pin 47 on this C1 connector here. Take a look at this wire here on the upper right hand corner. It's got a little number on the side of the connector. Let me see if I can clean it off. You can see it's got a 4 and a 7 stamp right next to it. So this is our pin number 47, and it's a pink wire with the gray tracer. The key is in the ignition, and the ignition is on. So let's take a look at the lab scope. And you can see we are showing full battery voltage, 12.32 volts. So what does that tell us? That tells us that our TIPM module is good. It's sending the power to the PCM. So the next step we need to do is we need to go down to the PCM and see if our power is actually getting there. All right, guys, so moving under the front of the truck here, you can see where our fan is located. And if you look right over here on the side of the engine, this is our PCM. And so you can see that there are 2 connectors here. Again, the C1 and the C2 connector. I'm going to disconnect them, look at the connector color and the pin count to verify which one is our C1 and which one is our C2 connector. Also, we need to remove these little plastic covers here, so we got to pull them off anyway. So as you can see, I have both connectors disconnected. And so what I found out is that this here is our C2 connector, and I am back probed on the pin number 71, which is our pink and gray wire coming from the TIPM module. And this connector over here is going to be our C1 connector. All right, guys, you know what? Because I'm already down here, I figured I may as well go ahead and back probe the pin number 65 on our C1 connector. Again, this is going to be the power supply coming from the PCM going to the fan clutch, and I have it attached to the lead for my channel 2 on my scope. So I've got both connectors installed. Let's move inside the truck and turn the ignition on. I've got the truck running. We have our scope down here. Let's take a look at our meter. So on our channel 1, we're seeing system voltage 14.2 volts. And again, our channel 1 is our input coming from the TIPM module. Now, if you guys take a look over at our channel 2, you can see that we're still showing only 3.9 volts coming out of the PCM. This is supposed to be our power supply for our fan clutch. Now, just to show you, I do have the fan clutch disconnected. So what we're seeing coming out of the PCM is not being affected by the fan clutch itself. All right, guys, so this is starting to look more and more like a bad PCM. However, before we can call a bad computer module, we have to do our basic powers and grounds checks. So let's go ahead and move back under the truck. All right, guys, so luckily our main powers and grounds are located right here. They are really easy to get to. And so you can see our 2 red wires. These are going to be our 2 main battery powers. And then right behind them, we have these 2 black wires. Those are going to be our 2 grounds. And so I'm going to start by back probing this red wire here. Now take a look at the power probe here. I've got my lead. It's coming from our back probe. I'm going to go ahead and clip it to the tip of the power probe. Let me turn the little beeper off. Sorry about that. I know it's kind of annoying. So take a look at the meter here. You can see that we have 12.6 volts, full battery voltage. Now I know some of you guys want to see me load test this power. And so I've got my test light here. It's got an incandescent light bulb in it. It is attached to a ground right now. And so I'm going to clip the end of this lead, and you guys can see that our test light lights up nice and brightly. So that shows that we do have a good power. Next up, I'm going to switch over to the other power. Get the back probe in there. Once again, looking at the power probe, I'm going to go ahead and clip my lead to the end here. And you guys can see we have full battery voltage, 12.6 volts. Then once again, we'll load test this power with our test light. You can see our test light lights nice and brightly. So both of our main powers are good. All right, so now I'm going to switch over to one of our grounds here. Take a look at the power probe again. I've got my lead. Let's go ahead and clip it on. And you guys can see we do show a good ground. Once again, I'm going to load test this ground. However, this time, the other end of my test light is connected to the battery positive. And so when I clip it to this lead here, this test light's going to be sending a power to our ground. So let's clip it on. And as you guys can see, the test light lights up nice and brightly. Then finally, we're going to switch over to our last ground. Now let's go check the meter. All right, so once again, back at our power probe, let's go ahead and connect the lead. We show a good ground. Now let's check it with the test light. I'm going to clip it on. We have a good ground. All right, guys, so there you have it. Our engine computer, PCM, ECM, whatever it is you want to call it, ours is faulty. Now, there are a couple things that are bothering me about this computer and what caused it to go bad. Our problem here is very specific. It seems to only be affecting the fan clutch control circuit. So I'm wondering whether or not the new fan clutch has anything to do with why the computer failed. Is it possible that the fan clutch they installed shorted out the circuit in the computer and caused it to fry the driver? It seems pretty likely. So one quick test that I'm performing, I want to show you guys. If you look at my lab scope up here at the top, I have it set to an ohm meter. And if you look down here, this is our connector for our fan clutch. And so what I did was I matched up the position of the pins here on this male side of the connector over to the female side coming from the fan clutch. And so you can see I've got my 2 leads probed onto the front of the connector here. So what I'm doing here is I'm getting a resistance measurement across the fan clutch. So if you guys take a look at our reading, you can see that we have an ohm reading that's pretty much infinity. This looks like an open circuit. This fan clutch is no good. Anyways, guys, I started to question my diagnostic when it came to the engine computer. I started to wonder if I was going about this all wrong. What if the engine computer is sending out a bias voltage of 3.9 volts? And what it expects to see is that 3.9 volts gets taken down to ground. When that bias voltage makes its way back to the computer after traveling through the fan clutch, the computer is grounding that circuit. And so as long as the computer sees that the 3.9 volts is getting pulled down to 0 volts, that's when it determines that it's okay to send out the full 12 volts. I hope what I'm saying makes sense, guys. But basically, on a good working circuit, we should never see that 3.9 volts. And if we do, it probably means that there's an open in the circuit. Because remember, guys, a bias voltage, before it comes out of the PCM, it travels through a resistor. And so what that means is that the bias voltage is a very low current voltage, and it's simply used for monitoring the circuit. Okay, so moving back over to the truck, let me show you what it is we're going to test. So if you look right here, you can see this is our connector for the fan clutch. This is part of the harness coming from the engine computer. And so I am back probed on our brown and light blue wire. This is our voltage feed coming from the engine computer that goes to the fan clutch. Now this back probe is attached to a lead, and this lead, I have it going over to this test light. Now, what I plan on doing is using this test light to bring our 3.9 volts down to ground. And the way I'm gonna do that is by connecting the other end of the test light to our battery negative. Now you can see I have the meter up here, and that's because at the same time, I wanna monitor the voltage here on the tip of the test light. And the way I'm going to do that is by simply connecting my lead to the tip of this test light. Now we can monitor the voltage here on our meter. And so the first thing I want to do is turn the ignition on, come back to the meter, and verify that we still have our 3.9 volts. Now I'm going to go ahead and connect the lead for our test light to the battery negative. We're going to watch the meter to see if it gets pulled down to ground. So I'm going to go ahead and connect it, keep an eye on this. And you guys can see we have successfully dropped our bias voltage to ground. Now the other giveaway that this is a bias voltage is that this 4 volts is not enough to even light our test light, not even a little bit. So now that we've brought our bias voltage down to ground, I'm gonna move inside the truck, turn the key off, and turn the key back on, and I wanna see whether or not our computer sends out the 12 volts. Okay guys, so I'm gonna move inside the truck and cycle the key on. All right guys, that's enough evidence for me. I don't think this truck needs an engine computer anymore. I think all we have to do is replace the fan clutch, and that should take care of that problem. I'm gonna run to the parts store, get a new fan clutch, install it, and we'll see what happens. All right guys, so I've got the fan clutch out, and I think I figured out where our problem is. So take a look down here. You can see that this here is the electronic part of the fan clutch, and this is the wiring harness that goes out to the fan shroud. Can you guys see what's wrong here? Our connector is unplugged. In fact, now that I look at it closer, it looks like the clip is actually broken. So this must have happened during the installation from the last mechanic. Now, I could probably just try to plug this thing in. However, I don't want to chance this thing coming back out, and so...
A few moments later.
All right guys, so I'm back from the parts store, and I went ahead and I picked up a brand new clutch. Now this one, I did decide to go with a different brand. In this case, we're using the Hayden aftermarket brand. Here's the part number, if you guys are curious. I couldn't get a hold of an OEM Mopar one, so this is gonna have to do for the meantime. Anyway, I'm gonna bolt this up to the fan blade, then reinstall it back into the truck. All right guys, so fast forward once again, I've got the fan clutch installed. Take a look right here, you can see I've got the new connector plugged in, and also went ahead and I taped up this wiring loom, made sure everything was nice and tucked up. Now, I have my lead still connected to our brown and blue wire, which is our power feed from the PCM. I've got the meter up here, and so now is the moment of truth. Let me go ahead and start this thing up. Okay guys, so we're actually showing 0 volts at the moment. So I'm starting to wonder whether or not this circuit is a pull-up design, meaning that the computer only sends out the 12 volts when it wants to activate the fan clutch. So if that were the case, then that means that the brown and pink wire going back to the computer is probably a ground at all times, not a pulse ground like I thought it was in the beginning. All right guys, so I pulled the scan tool out, and I wanted to check and see whether or not there was a bi-directional control for the fan clutch. And actually, what I found under the actuation menu is that we do have a fan clutch pulse width modulated duty cycle output control. Try saying that 10 times fast. So I'm gonna click on it. I'm gonna hit on. Oh, it says here that the conditions are not met. We probably need to let this thing warm up. Okay, so I've got the engine warmed up a little more. Let's try this again. We're gonna go into actuation test, fan clutch pulse width modulated duty cycle output. We're gonna hit on. Still not letting us. Okay guys, so I'm not really sure what parameters it is that we're not meeting. So I'm curious whether or not the engine has to be off in order to do this. So I'm gonna go back into the actuation test, and we're gonna try this with the engine off. And so again, we're going to try the fan actuator here. Oh, take a look right there. You can see our duty cycle control coming from our computer on this fan clutch circuit. Well, there you have it guys. As you can see, our computer is commanding the fan clutch on right now, and so it looks like everything is working properly. There are no more fault codes for the fan clutch stored in the ECM. I guess in order for us to run this test, we have to have the engine off. All right guys, so there you have it. We have fixed the problem. The next thing that I need to do is take this truck for a test drive to see if we fixed our overheating problem. All right guys, so I've been driving now for about 45 minutes or so, driving this thing pretty hard. It is late at night, however, and so I'm not sure, we might have to just take this with a grain of salt. However, the engine temperature looks pretty good. If you guys take a look at the screen, you can see that we're at 204 degrees Fahrenheit. If you look up at the gauge there, you can see that that's about halfway on the gauge. So we are well within the normal range for a temperature. Anyway, at this point, I'm gonna call it a night. The owner's gonna come pick up the truck tomorrow. I'm gonna give him a few days to drive it, maybe carry a few loads, and I will update you guys when I hear back from him. All right, guys, so there you have it. The story of how I almost put a $4,000 computer in a Dodge pickup truck. Now, I'm not exaggerating when I say $4,000 because I actually called the dealership just for grins and giggles, and they told me that this computer listed out at almost $4,000, which is insane to think about because that's probably the most expensive computer I've ever run across in any vehicle I've ever worked on, period. Anyway, luckily I caught my mistake. We were able to determine that our fan clutch was bad, even though supposedly the last mechanic that had it replaced it with a brand new one. Now, I don't really want to get into that conversation because, well, quite honestly, when I looked at the fan clutch that I pulled out of there, it did not look brand new. And when the customer tried to call the mechanic back, he wasn't picking up the phone. I even talked to him personally when the customer gave me his phone number and I asked him, where did you buy this fan clutch? And he claimed that he bought it at AutoZone. He gave me his phone number and all of that information. However, when I went to the AutoZone, they said that there was no record of it ever being purchased. And so after that, I tried to call him back. However, he stopped picking up the phone. Now, as far as the bias voltage goes, honestly, I wasn't familiar with this system on the Dodge. I did not know the 3.9 volts is what the manufacturer uses for a bias voltage. So that did kind of throw me off a little bit. However, now I know better. Like I've said before, I don't know everything. I don't claim to know everything. And anyone who does tell you that they know everything, well, they're full of. As far as the overheating condition, this fan clutch was definitely a fix. The customer's been driving it now for a few weeks, hauling all kinds of loads, and the truck still has not overheated. Anyways, guys, I hope this video was a helpful lesson for you. It was a lesson for me. Anytime I learn something new, I always love to share it with you guys. And so like I always say, I hope you found the video useful, informational, educational, entertaining. If you did, make sure to give it a thumbs up. If you haven't done so already, make sure you subscribe to the channel, hit that notification bell, and I'll see you guys in the next one. Thanks.